Hi everyone, very good evening and welcome back to Geeks for Geeks practice and welcome back to another problem of the day as well. So please give me a plus one in the chat guys and hit the like button if my voice is clearly audible to everyone and everything is working fine. Hi Madbar Joshi and hi to Rishit as well. I hope that I am clearly audible to all of you guys. So let me quickly share my screen so that we can start discussing the problem for yesterday. So I'll just share my screen guys, just give me a second. Yeah, so I hope that the screen is getting shared. All right. So the problem that we are going to discuss today is going to be maximum diameters, right? So maximum diamonds. Okay. So basically, this problem was the problem of the day for yesterday. So guys, you can hit the like button if everything is working fine for all of us, right? Okay. So in this problem, the problem says that there are n bags. Okay. So basically you can understand that you are having n bags. So basically this means that you are having n elements. Okay, so there will be an array, you can say, that will be of n size. Okay, so you'll be given an array and the ith element of the array. Okay, the ith element of the array will be having the value a of I, right? Because this array will be a. So the ith element will be having the value a of I, and it is going to tell us about the number of diamonds that are present. Okay, because there are n bags. So the ith bag, okay, in this case they are saying that the ith bag will contain ai number of diamonds, right? Ith bag will contain ai number of diamonds. Is this part clear to everyone till now? Right, the input is clear. You will be given the value n, so n indicates the number of bags, and in the ith bag there are initially ai number of diamonds. Okay, so the problem says that what you can do is, in one move, okay, in one move what you can do is you can choose like you can take a particular diamond, right? So let's say if you choose any ith bag. Okay, so suppose that ith bag has ai number of diamonds. Okay, so if ai number of diamonds are there, then what you will do is, if you drop a bag with ai diamonds, it changes to ai and you gain ai diamonds. So basically it says that, suppose that if you choose this ith bag having ai number of diamonds. Okay, in that case what happens is, in your amount, okay, in your total amount, the diamonds will get updated by a of I, so your total amount will increase by a of I, and then ai number of diamonds will reduce to ai by 2. So they will reduce by half. Is that clear to everyone? In one move what you can do is, you can choose any particular ith bag. Okay, you can choose any particular ith bag, that is, you can choose any particular a of I, and when you choose it, so this much of that much amount of diamond will be added to your account, and then this ai will get converted to ai by 2. Okay, this is the main point. Now in this case they are saying that you will be given k minutes. So basically you will be so basically this process takes 1 minute. So you can mark it as one move. Okay, in one move this happens. In one move you can select a particular ith bag a of I, and you in your amount ai will get added, and the amount diamond amount will get reduced by half. So it says that you can do it for k minutes. Basically it means that you can do it for k moves. Please write yes in the chat guys. Is this part clear to everyone? Basically what you have is, you have k number of move, because in one move what you can do is, you can choose any ith guy. So in your amount, what will happen, in your amount it will get increased by a of I, and then after that ai will get reduced to ai by 2. Okay, this is going to happen in 1 minute, or you can say in one move. Okay, so if you have k moves, if you have k minutes, right? So you can say that you have k moves. Okay, so if you're having k moves, then what will happen is, if you're having k moves, so you have to tell that at the end of the k moves, what is the maximum amount of diamond that you can collect. What is the maximum number of diamonds that you can collect? Is this part clear to everyone? Please give me a plus one in the chat and hit the like button as well guys, if everyone is clear till now. So in one move you can choose any a of I, and you can collect that much amount of diamond. Okay, so your amount will increase by this, and then this ai will get converted to ai by 2, so it will reduce by half. So if you have k moves or k minutes, so you have to tell that what is the maximum number of diamonds that you can collect. Yes Rishit, I will try to help you with the test case as well, don't worry on this part. So let us take this particular test case. Okay, so let us say that we have this particular test case, which is nothing but, first of all, let's say you have 2. Okay, then you have 1, then you have 7. Okay, then after that you have 4, and let me just do one thing. Let me put this in this kind of a container. So let's say you have 2, then you have 1. Okay, then you have 7, then you have 4, and then you have 2. Okay, and you have k is equal to 3, so you have 3 moves. Okay, so you have been given this element, I think 2 1 7 4 and 3 are the elements. Now you have been given 3 moves. Okay, you have been given 3 moves. So please tell me guys, which kind of elements would you like to take? Can I say that we will always try to take the maximum elements, right? Which type of diamond bag you will try to take out first, right? Can I say that at the very first move, right, you will take this particular bag? Correct, please write 7 in the chat. You will try to take the highest, or you can say mx in the chat, maximum in the chat. Okay, you will take the maximum diamond value back. Correct, the bag that is having the maximum number of diamonds. You will try it, in the first move you will take that one. Correct, yes. So in this particular case, what you will do is you will take this guy. Okay, so once you take this guy, so in your amount you will add this much diamond. So initially your amount was 0, so you will add this particular diamond, and this is one move. Okay, then after this, what you will do is when you take this diamond, right, so it was 7. Now when you had 7, so you divide it by, because you can assume it as a of I. So after that, when you are replacing it inside the bag again, so it will become ai by 2. So it will become 7 by 2, that is nothing but the integer value will be 3. So you will put 3 back. Please write 3 in the chat. Okay, so inside now you will put 3 back. Instead of 7 you will be putting 3. Is this part clear to everyone or not? Instead of 7, now you will put 3, because when you had 7, so you'll do 7 by 2, so this will be 3. So now you are going to put 3 inside. Is that clear guys? Okay, now which is the maximum guy that you will take, right? Like, see, now which guy will you take? Okay, there is a bag with number of diamond as 1. This bag has 2 diamonds, this bag has 3 diamonds, this bag has 2 diamonds, this bag has 4 diamonds. So which one would you like to pick? Can I say that you will pick the 4, the diamond, which is like the bag which is having 4 diamonds, right? So you are always going to pick the maximum, right? Please write mx in the chat. Okay, you are always going to do what? You are always going to pick the bag. Okay, always going to pick the bag with maximum diamonds, right? Pick the bag with maximum diamonds, right? Maximum diamonds at that point, right? At that point. Okay, this is very important. So can you tell me, when I say this, that I have to, like, see, when I will do this, so I will basically pick up this guy. So plus 4 will be added, and then this guy, 4, you will divide it by 2, and then you will put it back. Okay, so I think amount is not visible to all of you. No? Just a second. So yeah, amount will be what? Here it will be, you can see 7 was already picked, then after that I have picked 4. So 4 by 2 when I'll do, so it will be 2. So now I will, instead of that, I will insert 2 here. Now which, now you have used 2 moves up till now, right? Up till now you have used 2 moves. So now you have the third move. So which guy will you pick now? Anybody can tell me in the chat, which bag will you pick? Which bag are you going to pick now? Everyone in the chat, please tell me. And also hit the like button if you are getting the intuition behind this particular question. Guys, hit the like button as well if you are clear till now. Okay, so yeah, now you will pick the bag as 3. Okay, so now since you are going to pick the bag with this value as 3, so plus 3 will be added to your account, and now 3 divided by 2 will become what? 1. So now it is going to be replaced with the value as 1 as the updated value. So in the 3 moves, you are, in the first move you collected 7 diamonds, in the second one you collected 4 diamonds, in the third you collected 3 diamonds. So in that case, total you have collected how much? 14. So I think so that 14 is going to be the final answer, and you can see that 14 is the answer. Please write clear in the chat if you are clear with this thing, because you can see that the output is coming out to be 14. If you are clear till now, so guys, please hit the like button and give me a +1 in the chat as well. Is everyone clear till now? I can see that the likes are not increasing. So if you are clear, you can tell me till now. Guys, is that clear? Okay. So now the thing is that at a point of time, okay, what is happening? At one point of time, right? At one point of time, you are picking the maximum value, right? Maximum element. Okay. If you are picking the maximum element, so what can I say? So maybe you can do, you can traverse through the n elements. Okay, in one move. Okay, in one move, what you're doing, I will tell you. See, in one move you are picking the maximum element. In every move you are picking the maximum element. So in a particular move you are picking up the maximum element. And for finding the maximum element, why you stop at 2? Because I had 3 moves. The total k value was 3. Okay, total k value was 3, so that is why I had stopped, because I only can apply this for 3 times, because the k value was 3. Why divide? Because it is asked in the question. Okay, it says that if you take ai number of diamonds, so now ai will change to ai by 2. Okay, yeah. So because k value was 3 here, no, so I can only do it for 3 times. So for one time I did here, second time and third time. right? So for one move you can notice that if you will if you for every move you are going to take the maximum element always. So for one move if you will take the maximum element, so it is going to take how much time? Can I say that for one move it will take order of n time? Please write yes in the chat if you agree with me, guys. For one move it is going to take order of n time. So if you are going to apply it for let's say k number of moves, okay, or k number of minutes, you can say, right? Then in that case, how much time it is going to take? Order of n into k it is going to take. Correct? Please write yes in the chat. Right. So this is what is going to happen. And can we sort the array? If you will sort the array, then it will take more time. If you are going to sort the array and then find the maximum element, so in that case, see, if you will sort the array and then find the maximum element, so for one move you will take n log n time. Okay. Then for k moves you will take how much time? K into n into log n. Okay. If you use the sorting method, then this will be the method one, you can say, right? This will be the method one. If you sort and find the maximum element at one move, at every move, so one move will take n log n time, because if you are sorting, then then after that it is not then after that again you have to sort now for finding the maximum amongst them. So then you will use again n log n every time. So for one move you will take n log n. So for k moves you will take k into n into log n, which is very high. But in the second method, as I discussed in the method 2, if you are finding the maximum element by iterating through the array, so that will take order of n time. And if you are doing it for k moves, so it will take n into k time, right? This is going to happen. Is it clear till now to everyone? Please hit the like button and give me a +1, guys, if you are clear till now, and then I will proceed further. Okay, so we need to do what? We need to have a data structure, like we need to have something, right? So if you could understand this thing, suppose that if I had 8 guys, okay, suppose I had 8, I had 6, I had 3, I had 2, and I had 1. Okay, now suppose that what I did was, if I picked up this guy, right? Suppose that I picked up this guy 8. Okay, now this is the method 3. So suppose that if I pick this guy up, right, if I pick this guy 8, so in that case what you will do is you will remove it, and like you 8 will get added to your amount, that is fine. But after that you will replace this with 4. So now after that, if you are going to apply this next move now, then 6 will be the next maximum element. Please write yes in the chat. Now 6 will be the greatest element, correct? When you are going to take the second move, so the element that you are going to pick is nothing but 6, right? So we need to take the help of a particular data structure that can help us, that can sort the element that can sort the elements for us in a very faster time, right? That can give us the maximum element at the top. Okay, so is there any data structure? I had discussed about this yesterday as well. Is there any data structure, guys, that I can use? So yes, there is a data structure. Basically what I can do is, if I can store all the elements in a heap, and to be precise in a max heap. Okay, if I store all the elements in a heap, max heap, so what happens is, if there are n elements at a particular point of time in a heap, right, then in that case, for giving the maximum element at the top, the heapify process takes log n time. Okay, so for getting the so at one point of time, okay, for one move, getting the maximum element takes log of n time. Okay, so in that case what will happen, if you are doing it for k number of moves now, then the complexity will be kind of k log n. Okay, so which is going to be very very efficient for us. Is that clear, guys? Are you getting my point? So this is better. Okay, instead of c, earlier you were having c, you have also discussed, first was k into n log n. Okay, this was the first complexity. Then we discussed k into n also, and after that now we are discussing k into log n. That is the method that I told you, right? So we need a data structure that can efficiently give us this thing. That will be nothing but priority queue, or you can say max heap here, right? So k into log n. So this is the best complexity that we can achieve. Is that clear? Please write clear in the chat or yes in the chat. Is this part clear? So basically having a max heap does what? Let's say after this, like see, if you have these elements, if you have inserted these elements, so there, suppose these are n elements, so it will take log n time to bring the maximum, to keep the maximum element at the top. Okay, it will be kind of in terms of binary, it is implemented in terms of, I think, BST. So at that point what will happen, you can always say that the maximum element will be at the top, so you will be able to access it. Can you explain max heap basic, how it works? So basically now it is implemented in the form of tree. Okay, B drive, the max heap is implemented in the form of a tree. So basically what happens is, for finding the, if it is a max heap, so it will always keep the maximum element at the top, and if it is a min heap, so it will always give you the minimum element at the top. Okay, and suppose that you take this guy, right? So when you put this guys, so it will take log n time to keep 8 at the top. Okay, so 8 will be at the top, and then when you will take out 8 and you will use it, then when you will push 4 inside now, then the data will get rearranged. Okay, when you have used 8, and then after that when you will put 4 inside, then all the n elements will again get rearranged. That process is known as nothing but heapify process, for bringing the maximum element, current maximum element at the top from amongst the elements that are present. So that takes log n time. As I said, for one move it takes log n time. So again the maximum element will be there, so now 6 will come at the top when you will iterate, when you will check. So that is why max heap is going to get used. Is this part clear to everyone? Please write yes or no in the chat, guys, and please hit the like button if you are clear with this, right? So every time I keep on doing this, because now after that when I will use this, suppose, then 3 will be put instead of this. So from amongst these elements I need the maximum element. So maximum element is going to be what? It is going to be 4. So again the heapify process will take logarithmic of n time. So for one move it is for one move, for keeping the maximum element at the top, it takes log n time. So for k number of moves it takes k into log n time, right? So that is why this is very uh, simpler complexity, very much less complexity. Okay, I will tell you about the syntax. I will be writing the code for it. But is this much part clear to everyone, guys? Please tell me. So if you, as I said, for one move, what happens is the heapify process takes order of log n time, guys. Okay. So if you are talking about k moves, so in that case, what will happen? The complexity will be order of k log of n. Okay. Then in this case, you can observe that it will be k log n, right? So that is why you can say that it is going to be this much. And so this was the time complexity. Talking about the space, so since I am storing all the n elements inside the heap, so I will take order of n space complexity, right? So because I'm going to store all the elements here. So is this much part clear? Please write clear in the chat and +1 in the chat. Then I will discuss the syntax and the code part also. Guys, you can hit the like button as well if you are clear till now. So whenever it happens now that you want the that you want to get the elements, right? That whenever it happens that you want to get the minimum element or maximum element within a fraction of a second, then which data structure do you use? You use the heap data structure, that is priority queue, may heap or max heap depending on the circumstances. Okay, so I will declare a max heap here in C++, right? So priority underscore QUEUE, okay, and this will be int PQ. So this is in C++. Similar kind of things will be done in Java as well. And then I will iterate through the array first of all. So I starts from 0, I is less than the size of the array, and then I will do an I++. So the first thing is that I will be pushing all the elements into the priority queue. Okay, so I'll push all the elements into the priority queue one by one, and then I will declare that long, let's say answer, initially I will mark it as 0. Okay, so initially I'm going to mark the answer value as 0, that is the total amount that I will be collecting. And then we will iterate for how many times? We will iterate for k number of times. So let's say int I starts from 1 and I is less than equal to k. So for k number of times the process is going to take place. Okay, then what we will do here is we will simply say that first of all we'll pick the value. So let me do it. Okay, in the current, we'll pick the current top guy. So it will be nothing but picked by using pq.top, and once I have picked it up, so I have to remove it as well. Okay, so I'll pop it out, because if I had suppose I have 8 here. Okay, if you will talk about this particular place, so suppose that I am having 8 here. So when I'm having 8 and when I'm using it, so I'm removing it now, because instead of this, what I'm going to put it, I'm going to put 4 here. Are you getting my point? Or suppose if I have got something like what, let's say if I have got something like 7, then when I will use the topmost element, largest element here, because this is a max heap, then after that instead of this I have to put ai by 2, so I have to put 3. So first thing is that I have to not only use the 7 value, I have to also remove it. So that is why I'll remove it by making using the help of pop function. Okay guys, so this is what I am going to do. And then after that I will insert ai by 2 inside the array, inside this max heap. Okay, so here I will insert 7 by 2, that is nothing but 3 here. Is this part clear? And what are the alternative of max heap in the code? What are the other alternative? Actually this question needs to be done using the heap only. There is no alternative for heap here. Okay, so yeah, I will add it in my amount also. So I'll say that okay, answer plus is equal to current. Okay, so this guy I will add also, and then I will do what? I will now push what will I push, guys? I'll push the current value that I have taken divided by 2, right? So whatever current guy I had taken out, I had popped out, right? So I will first of all store it, then I'll pop it out. So suppose I had 7, so I'll store it in the current and I'll pop it out. And then after that I will, instead of that, I'll store what inside the priority queue? I'll store inside the max heap, I'll store current by 2, and then again the heapify process will take log n time. So this is how it is going to happen, and then we can simply return the answer here. Is this much part clear to you, all of you guys? Please tell me. Is it clear, guys? Till now, does it make sense? You can hit the like button and give me a plus one, guys. I think this is capital K here, right? If you are clear till now, then you can let me know, and please hit the like button as well, guys, if you are clear till now. Okay, so you can see that it is working fine for the sample test case. Let's now try and submit this code to check if it is working or not. Yeah, I can try to give it from the discussion section. No worries. Post your approach in the comment section. So, is this much part clear? So basically, what you do is, first of all, I'm telling you about this. Okay, B drive. So I will show you the Java code also. See, what we are doing here is we are first of all declaring a max heap, because we always want the maximum elements at the top. So because we want the largest elements to take, right? So we are using a max heap. Then what we are doing is we are pushing all the elements inside the max heap. So maximum element will get at the top. Then after this, what is going to happen here is that inside the answer will mark it as 0, and then what we are going to do is we are going to iterate for k times. We are always going to take the topmost guy, that is the maximum guy. After taking it, we are going to pop it out, we are going to add it in the answer, and then inside the data structure, that is max heap, now we will push current divide by 2, and in the end we return the answer. So this is how we are doing it. Just give me a second, I will paste the solution link as well. But is it clear to everyone till now or not, guys? Please tell me. I hope that all of you are very much clear with this, right, guys? All right, just give me a second. And yeah, this kind of question has been asked sometimes in some of the companies or in code forces rounds also. So that is why you can think that it is of quite importance itself, right? So yeah, binary search will not work. No, binary search. Binary search. Why do you want to use binary search? Because you always have to find the maximum element, no? So how binary search is going to work here? Binary search works on the sorted array, no? So that is why. Okay. So you can see that I have pasted this thing, and also I'll show you the Java code. So just give me a second. I'll show you the full solution here. Okay. So you can see clearly here, like if you are talking about Java, so this will be the priority queue, because by default in Java, the basic by default in Java, the priority queue is implemented in main heap. So you are declaring a max heap here, and then you are putting all the elements, and after that you are doing the same thing that I was doing, right? You take out the peak element, okay, and then you remove it, and you simply do what you simply put the topmost element divided by 2. So is that clear? Yes, I think I am not in very much good health, because yeah, you can see I am not able to speak properly. But Bar, thanks a lot for your concerns. Yeah, so is this part clear? You basically can do it in this way in Java. So maybe I can paste this code also for all of you. Just give me a second. So I will generate another link in Java, and I can paste it for all of you. Okay, yeah. So what I will do is I'll share this piece of code with all of you. Just give me a second, and this will be the Java code, right? Java code. So yeah, I hope that you all enjoyed this particular session. So I've just pasted the Java snippet actually. Okay, like basically what you will be doing. So you can see here, basically the first step will be for declaring the max heap in Java. So if you will just search on GFD, na max heap in Java, so this syntax will come. Okay, so by default, normally if you will not write collection dot reverse, so it will be min heap in Java. But if you want to declare max heap in Java, then this is the syntax. Then you put all the elements one by one, and you declare the answer as 0. Then you can just iterate a while loop. Okay, k number of times, keep on adding the element, and then push the top element divide by 2. So that is how you can do it. Well explained. Thanks a lot, B Drive. I hope that everyone has clearly understood this particular approach. Right. So yeah, this was the problem, and it was a very good problem, to be honest. Like it is a very good problem when you talk about the normal scenarios, because I think there is one more problem that is there on GFG. I'm not sure what is the name of. Yeah, rope connecting problem, right? So there is. I can tell you also, right? There is rope. CONNEC connecting. Let's say GFG. If I'll write something like this, let me just check. Connect n ropes with minimum cost. Yeah, minimum cost of the ropes. Okay. So yeah, there is this particular problem that is there. You can try this problem out. Okay. In this problem, it says that what you can do is the uh, similar kind of approach is there. So like just a little difference is there, but ideology remains the same. So there are n ropes of different lengths. and we need to connect this into one rope. So the cost of connecting two ropes is equal to the sum of their lengths. Okay, so if you connect two ropes, then you will get the cost for you will be what? The cost for you will be like if you're connecting 3 plus 2, so cost for it will be 5. So you want to ultimately connect with the minimum cost. So if I will just tell you, suppose this particular question is there, okay, and this has been asked in some companies also, I think you can see here. If I'll move down a bit, so you can see Amazon, Microsoft, Oyo, Goldman Sachs. Okay, so let's take this particular test case for example. Okay, so if you will see here, so if you suppose have two, then you have three. Okay, then after that you have four, and then you have six. Okay, so if you will observe now, so if you are going to connect two ropes, let's say you will so always it will be better to connect the smaller ropes, because whenever you are going to connect, so let's say you connect these two, so it will become five, they will become five, and the cost added will be five for them. Okay, so in this case what is going to happen, suppose that you connect these two. Okay, then in that case what will happen, in place of this you will put 5 here, right? And the cost will get added as 5, right? After that, again you are going to connect. So suppose that if you connect the higher people, if you connect this and this, so the cost will be higher. So you'll always connect the two smallest every time. Okay, so you'll connect this and this, then the cost for this will be 5 plus 4, that is nothing but 9. Okay, and this guy will become 9 here, and then you will connect these two. Then so what will be the cost? I think the cost will be this much, 15, right? So this will get converted into 15, so plus 15 also. So you can see that the total cost is going to be what? 5 plus 19 plus 15, 5 plus 9 plus 15. So I think it is going to be nothing but 29, right? So you can see here that the answer is also 29. So here in this case you always want to connect the two minimums. Are you getting my point? If you want to reduce the cost here, so इसमें n by 2 नहीं करना है. No, इसमें क्या, in this what you have to do is ना, you have to basically when you are, see, if you will see, so I got the minimum cost because I always kept on adding the two minimums. Is that clear, guys? प्रीवियस क्वेश्चन से रिलेशन ये है कि डेटा स्ट्रक्चर सेम यूज हो रहा है. ओके, सपोज दैट इफ यू हैव दिस थिंग, राइट? If you have I will tell you what can go wrong for you. Okay, suppose that somebody will think that if they have 4, then you have 3, then you have 2, and then you have 6. What you have? Suppose that you have 6. Okay, when you connect these two, so it will become what? It will become 8. So you will have 4, 3, 8. Suppose you are connecting the smaller and the larger one, then the cost you will pay is 8. Then after that, suppose you connect these two, then the cost that you will pay is 11, and this will be 4 and 11. Then you connect these two, so the cost that you will pay is 15, right? So the total cost is going to be what here? It will be, I think, 26 plus 8. So this is going to be what? 26 plus 8 is going to be, I think, 34, right? So in this case you can see the cost is very high, right? So you always want to connect the, if you want to minimize the cost at every step, so you'll always connect the two minimum. Is that clear? Please write yes in the chat, guys, if you're getting my point. Okay, so in that case what you will always try to do is you'll always try to connect the two minimum ropes. Okay, so that is why because you can see now, if I just connect it randomly, or let's say if I connect the smallest and the largest at every step, then I'm getting the cost as 34. Others can also write yes in the chat if they are there present with us. If you will see here, suppose that if I had what if I had something like, just give me a second, if I have 4, 3, then I have 2, and then 6. So at every step you have to reduce the cost. So when you will connect these two, right, so the cost will be 5 for that. Then after that it will become 4, 5, and 6. Then again you will connect the least smallest two, so you will connect this and this, right? So this will be what? 9 and 6. So the cost you will get is 9. Then after that you will connect these two, so the cost for this will be 15. Okay, so plus 15. So that is how you are going to get the answer as what 15 plus 5 is 20, plus 9 is 29. So that is how you are going to get the minimum cost as 29. Okay, because it says that you have to get the minimum cost that you can get by connecting the ropes. Okay, so you have to try and get the minimum cost for yourself. Okay, so that is why, since you want to get the minimum cost, so you need a data structure that can efficiently give you the minimum elements at the top, right? So that is why you will use a min heap here. Is that clear? Please write yes in the chat. So in this question you will use a min heap. Are you getting my point, guys? So yeah, that's and this question has been asked in some companies also. You can observe that as well on your own. So that is why this question is also important, and it has been asked in companies also. And larger variations are based on this smaller variations itself. So practice question, I'm giving it practice question. Okay, yeah, I hope that you like this one. Okay, same as last question, very similar, not exactly similar as I can say. So if I have the code, I'll just show you this one as well. Okay, So yeah, you can see here now what I'm doing here is, you can clearly see. So I have declared a mean heap here. Okay, then I push all the elements, and initially I mark the cost as 0. And what will be the condition that I'll keep on running? Because I'll keep on running until I have two or more elements. Okay, because until I only have one element, right, until I have connected it into a single rope, then only I stop. Now you can see when the size becomes 1, then only I stop. So if the size of the priority queue, because all these elements kind of will be in the priority queue only. Okay, so when the size of the priority queue is greater equal to 2, then I'll keep on doing this process. What I will do is I'll take out the first element. Okay, so I will take out the current minimum element and I'll pop it out. Then again the hippify will happen, and then I will take out the top again, so that will give the next minimum. Okay, then I will add their cost, and I will push the first plus second here, and ultimately I'll return the cost. So this is how you can do it. So yeah, this is a very good question as well, and it has been asked, as I already said, that it has been asked in the companies as well. You can, if you move down the order a bit, so just give me a second. You can see that that is very much clearly visible here. Just a second. So yeah, you can see here Amazon, Microsoft, Oyo, and Goldman Sachs have asked this. So it is also a good problem, and there can be more variations to it as well. Okay, so I hope that you did like the session, guys. Right? Did you enjoyed this session and learn something new? If yes, then please give me a +1. And after this video is over, so make sure to hit the like button if you haven't already. If you're watching the recording as well, you can share this with your friends. Make sure to solve the problem of the day for today, that is going on, right, from 12 a.m. that is going on. So make sure to solve it. I think it is a very interesting problem, and I'll be solving it tomorrow in front of all of you. I hope that you enjoyed it. Thanks a lot, guys, and I'll see you with another POD tomorrow. Till then, good night, take care, and keep coding, guys. Keep being consistent, keep upgrading yourself, keep upskilling yourself, and keep faith in yourselves. Thanks a lot, guys, and keep coding.